This is Chapter 3, Book 2 of A Journey in Other Worlds. This LibriVox recording is in the public domain. Recording by Tom Weiss. A Journey in Other Worlds. Book 2, Chapter 3, Heavenly Bodies. The following day, while in their observatory, they saw something not many miles ahead. They watched it for hours, and in fact all day, but notwithstanding their tremendous speed, they came but little nearer. "They say a stern chase is a long one," said Bearwarden, "but that beats anything I have ever seen." After a while, however, they found they were nearer, the time taken having been in part due to the deceptive distance, which was greater than they supposed. "A comet!" exclaimed Cortlandt excitedly. "We shall really be able to examine it near." "It's going in our direction," said Ayrault, "and at almost exactly our speed." While the sun shone full upon it, they brought their camera into play, and again succeeded in photographing a heavenly body at close range. The nucleus, or head, was of course turned towards the sun, while the tail, which they could see faintly, preceded it, as the comet was receding towards the cold and dark depths of space. The head was only a few miles in diameter, for it was a small comet, and was composed of grains and masses of stone and meteoric iron. Many of the grains were no larger than peas or mustard seeds. No mass was more than 4 feet in diameter, and all of them had very irregular shapes. The space between the particles was never less than 100 times their masses. "We can move about within it," said Ayrault, as the Callisto entered the aggregation of particles, and moved slowly forward among them. The windows in the dome, being made of toughened glass, set somewhat slantingly so as to deflect anything touching them, and having, moreover, the pressure of the inside air to sustain them, were fairly safe, while the windows in the sides and base were but little exposed. Whenever a large mass seemed dangerously near the glass, they applied an apergetic shock to it, and sent it kiting among its fellows. At these times the Callisto recoiled slightly also, the resulting motion in either being in inverse ratio to its weight. There was constant and incessant movement among the individual fragments, but it was not rotary. Nothing seemed to be revolving about anything else. All were moving, apparently swinging back and forth, but no collisions took place. When the separate particles got more than a certain distance apart, they reapproached one another, but when seemingly within about 100 diameters of each other, they swung off in some other direction. The motion was like that of innumerable harp strings, which may approach but never strike one another. After a time, the Callisto seemed to become endowed with the same property that the fragments possessed, for it and they repelled one another on a near approach, after which nothing came very near. Much of the material was like slag from a furnace, having evidently been partly fused. Whether this heat was the result of collision, or of its near approach to the sun at perihelion, they could not tell, though the latter explanation seemed most simple and probable. When at about the centre of the nucleus, they were in semi-darkness, not twilight, for any ray that succeeded in penetrating was dazzlingly brilliant, and the shadows, their own included, were inky black. As they approached the farther side, and the sunlight decreased, they found that a diffused luminosity pervaded everything. It was sufficiently bright to enable them to see the dark side of the meteoric masses, and, on emerging from the nucleus in total darkness, they found the shadow stretching thousands of miles before them into space. "I now understand," said Bearwarden, "why stars of the 6th and 7th magnitude can be seen through thousands of miles of a comet's tail. It is simply because there is nothing in it. The reason any stars are obscured is because the light in the tail, however faint, is brighter than they, and that light is all the caudal appendage consists of, though what produces it, I confess, I am unable to explain. I also see why the tail always stretches away from the sun, because near by it is overwhelmed by the more powerful light. In fact, I suspect it is principally in the comet's shadow that the tail is visible. It is strange that no one ever thought of that before, or that anyone feared the earth's passing through the tail of a comet. It is obvious to me, now, that if there were any material substance, any gas, however rarefied, in this hair-like accompaniment, it would immediately fall to the comparatively heavy head, and surround that as a center." "How, then," asked Cortlandt, "do you account for the spaces between those stones? However slight gravitation might be between some of the grains, if it existed at all, or was opposed by some other force, with sufficient time, and they have eternity, every comet would come together like a planet into one solid mass. Perhaps some similar force maintains gases in the distended tail, though I know of no such, or even any analogous manifestation on earth. If the law on which we have been brought up, that every atom in the universe attracts every other atom, were without exceptions or modifications, that comet could not continue to exist in its present form. Until we get some additional illustration, however, we shall be short of data with which to formulate any iconoclastic hypothesis. The source of light, I must admit, also puzzles me greatly. There is certainly no heat to which we can attribute it." Having gone beyond the fragments, they applied a strong repulsion charge to the comet, creating thereby a perfect whirlpool among its particles, and quickly left it. Half an hour later they again shut off the current, as the Callisto's speed was sufficient. For some time they had been in the belt of asteroids, but as yet they had seen none near. The morning following their experience with the comet, however, they went to their observatory after breakfast as usual, and, on pointing their glasses forward, espied a comparatively large body before them, a little to their right. "That must be Pallas," said Cortlandt, scrutinizing it closely. "It was discovered by Olbers in 1802, and was the second asteroid found, Ceres having been the first in 1801. It has a diameter of about 300 miles, being one of the largest of these small planets. The most wonderful thing about it is the inclination of its orbit, 35 degrees, to the plane of the ecliptic, which means that at each revolution in its orbit it swings that much above and below the imaginary plane cutting the sun at its equator, from which the earth and other larger planets vary but little. This, no doubt, is due to the near approach and disturbing attraction of some large comet, or else it was flung above and below the ordinary plane in the catastrophe that we think befell the large planet that doubtless formerly existed where we now find this swarm. You can see that its path makes a considerable angle to the plane of the ecliptic, and that it is now about crossing the line. It soon presented the phase of a half moon, but the waviness of the straight line, as in the case of Venus and Mercury, showed that the size of the mountains must be tremendous compared with the mass of the body, some of them being obviously 15 miles high. The intense blackness of the shadows, as on the moon, convinced them there was no trace of atmosphere. "There being no air," said Cortlandt, "it is safe to assume there is no water, which helps to account for the great inequalities on the body's surface, since the mountains will seem higher when surrounded by dry ocean bottom than they would if water came halfway up their sides. Undoubtedly, however, the main cause of their height is the slight effect of gravitation on an asteroid, and the fact that the shrinking of the interior, and consequent folding of the crust in ridges, may have continued for a time after there was no longer water on the surface to cut them down. The temperature and condition of a body," continued Cortlandt, "seem to depend entirely on its size. In the sun we have an incandescent gaseous star, though its spots and the color of its rays show that it is becoming aged, or, to be more accurate, advanced in its evolutionary development. Then comes a great jump, for Jupiter has but about 1/1400th of the mass of the sun, and we expect to find on it a firm crust, and that the planet itself is at about the 4th or 5th period of development, described by Moses as days. Saturn is doubtless somewhat more advanced. The earth, we know, has been habitable many hundreds of thousands or millions of years, though 3/4 of its surface is still covered by water. In Mars we see a further step, 3/4 of its surface being land. In Mercury, could we study it better, or in the larger satellites of Jupiter or Saturn, we might find a stepping stone from Mars to the moon, perhaps with no water, but still having air, and being habitable in all other respects. In our own satellite we see a world that has died, though its death from an astronomical point of view is comparatively recent, while this little Pallas has been dead longer, being probably chilled through and through. From this I conclude that all bodies in the solar system had one genesis, and were part of the same nebulous mass. But this does not include the other systems and nebulae, for, compared with them, our sun, as we have seen, is itself advanced and small beside such stars as Sirius, having diameters of 12,000,000 miles. As they left Pallas between themselves and the sun, it became a crescent, and finally disappeared. 2 days later they sighted another asteroid exactly ahead. They examined it closely, and concluded it must be Hilda, put down in the astronomies as number 153, and having almost the greatest mean distance of any of these small bodies from the sun. When they were so near that the disk was plainly visible to the unaided eye, Hilda passed between them and Jupiter, eclipsing it. To their surprise, the light was not instantly shut off, as when the moon occults a star, but there was evident refraction. "By George!" said Bearwarden, "here is an asteroid that has an atmosphere." There was no mistaking it. They soon discovered a small ice cap at one pole, and then made out oceans and continents, with mountains, forests, rivers, and green fields. The sight lasted but a few moments before they swept by, but they secured several photographs, and carried a vivid impression in their minds. Hilda appeared to be about 200 miles in diameter. "How do you account for that living world?" Bearwarden asked Cortlandt, "on your theory of size and longevity?" "There are two explanations," replied Cortlandt. if the theory, as I still believe, is correct. Hilda has either been brought to this system from some other less matured in the train of a comet, and been captured by the immense power of Jupiter, which might account for the eccentricity of its orbit, or some accident has happened to rejuvenate it here. A collision with another minor planet, moving in an orbit that crossed its own, or with the head of a large comet, would have reconverted it into a star, perhaps after it had long been cold. A comet may first have so changed the course of one of two small bodies as to make them collide. This seems to me the most plausible theory. Over 100 years ago, the English astronomer Chambers wrote of having found traces of atmosphere in some of the minor planets, but it was generally thought he was mistaken. One reason we know so little about this great swarm of minor planets is, that till recently none of them showed a disk to the telescope. Inasmuch as only their light was visible, they were indistinguishable from stars, except by their slow motion. 100 years ago, only 350 had been discovered. Our photographic star charts have since then shown the number recorded to exceed 1,000. This is the end of Chapter 3 in Book 2 of A Journey in Other Worlds. Recording by Tom Weiss.